Mike Giles with SuperFlow, and I want to discuss some of the best practices for mounting engines to your Powermark dynamometer. We're going to talk about some of the tools we have available to help you do that, and then show you a few examples of how that might look in your test cell. So the first priority when connecting the engine to the dyno is to make sure we eliminate all the rotational vibrations created by the engine from reaching the engine cart, reaching the dynamometer stand, and ultimately reaching the load cell. We want to do this so we get really clean data into the load cell, because if these vibrations get there, our torque signal isn't very good. So we have a couple different tools we use to do this, and we take a few extra steps along the way, but the result is we bring good data into the load cell, and we get good data out of the load cell for you to evaluate your engines with. So then what tools do we use to separate engine vibrations from either a Powermark or a Black Widow dynamometer? First would be for any connections to the cart. We use these early Chevy vibration dampening mounts from Energy Suspension. They're polyurethane on the inside so that any vibrations from the engine actually are separated from anywhere it mounts to the cart by the polyurethane. So there's a Chevy version of those, and then we also employ just a standard transmission mount version of those for a couple different reasons we'll talk about in a little bit. And then next, for anything coming out of the crankshaft, we use this torsionally compliant drive shaft. Now it doesn't look like much, but there's actually a lot going on in this drive shaft. It's made up of a small inner tube and then a wider outer tube, and they're isolated from each other with a specific durometer of rubber, so that any of the vibrations coming from the back of the engine are actually eaten up in the rubber and they never make it into the load cell in the dynamometer. And then another feature worth noting while we're talking about it is we use CV joints on the drive shafts. You'll find a lot of people use U-joints because they're cheap, but that's not a good idea. There's a couple reasons why. The U-joints make a lot of noise on the load cell. Every time the U-joint rolls over or re-engages itself, which happens twice per engine revolution, it creates a big spike in the torque signal. So by default, if you use a U-joint, you're going to have a bad torque signal. So always use CV joints. They provide smooth power transfer, and they give us a really nice, clean, smooth torque signal, so that whatever data we bring into the dynamometer and we send to your computer, we know it's good. So we discussed a little bit of the parts and pieces we have to help adapt engines to the dynamometer. Now let's talk about the first step in that process, which would be the engine cart itself. So this end of the engine cart's for the front of the engine. These front adapters slide up and down the cart on these rails, and then they swivel in and out to accommodate a wide range of engines. And the height adjustment for different motor mounts is done with this threaded rod here. One other thing to remember about the engine actually is it's on cart, or it's on wheels. So a lot of guys will buy 2 or 3 of these and have engines dressed and on the cart ready to go on the dyno at all times, especially when they're busy, you know, in early spring when everybody calls and wants their engines yesterday. And the back of the cart here has this alignment bar and latches. In the alignment bar, you see there's 2 pilots here. On the front of the dynamometer base on both the Powermark and the Black Widow, there's 2 dowels that'll line up with these. So really all you got to do to dock the engine once it's mounted to the cart is push it onto the dowels, and then there's some over-centering clamps that'll tighten it down to the base. So we have several different accessories that can be used to adapt engines to the engine cart like we have here, and then also from the flywheels to the front of the dyno drive shaft. So we'll start with our rear engine adaptation. These mounting hoops, or the toilet seats, as we affectionately call them, have different bell housing patterns. This one here is our DT1271. It's really the universal small block one, so you got your small block and big block Chevy, and then the rest of your domestic small block patterns in it. It's got locating holes for the dowel pins and of course the bell housing patterns. And if you have one that doesn't line up, you can feel free to add additional holes here. So these are quite versatile. And this one right next to it is Big Brother. This is the DT1272, and this has the domestic big block patterns in it. So from there we move down to front engine adaptation, which we discussed a little bit already. We employ both these transmission mounts stacked on top of just a square mount, and then either a conical shaped adapter or maybe right to the bottom of a Ford motor plate. We also use this early Chevy Energy Suspension mount and our half moon shaped adapter here to sit right on top of the engine cart and catch the front of a Chevy engine block. And then for flywheel and drive shaft adaptation, we have several different options. The good thing to remember about Powermarks and Black Widows is since they're drive shaft driven, they're really versatile because they don't require a bell housing to adapt to. So this plate here is our DT1204 universal flywheel adapter. We've already installed the CV joint, so at this point, if this was mounted to the back of the engine, we could just bring the engine cart in and slide it right onto the end of the drive shaft. The 1204 has, again, several patterns for different domestic V8 flywheels, but just like the rear engine adapters, you can put any pattern you want in these. So then for harsh engines, let's say we've got a Pro Stock engine we want to run on our Powermark. We have this DT1248 inertia wheel. So you can see it's fairly thick, weighs about 35 pounds, and it's large in diameter. So in an engine test cell environment, we don't have the benefit of the weight of the vehicle, the suspension, or the tires to absorb some of the energy and harshness of the engine. So we use the inertia in this DT1248 for situations like that. And then one final option for unique adaptation is our DT1212, and these are just crank button adapters. So it's got the mating pattern machined in it for our CV joint, and then it has different crank patterns in it, or we also make these as blanks so you can put your own crank pattern in it. So the cart, again, is very versatile in the different ways that it can adapt to engines. So I've set up a few different examples here. We'll start on the left side over here. This is a typical Chevy solution. Again, we've used these vibration dampening mounts from Energy Suspension attached to our PM1151 that's then bolted to the threaded rod on the cart. This example here, and we'll show it on your screen, actually mounted to an engine, would be a typical Ford setup. So here we got our part number PM1149 and the Energy Suspension transmission mounts we looked at earlier, and from here your Ford motor mount would drop right down and bolt to the top of this. Then over here we've got an example of a conical shaped adapter. These are perfect for motor plate engines, like a lot of sprint cars or drag motors, or also they can be rotated this way if your engine happened to have a fixed mount somewhere up on the block over here. So these are pretty versatile because, again, they can rotate 90 or 180 with the engine, and we still incorporate torsional compliance right here in the adapter. So now that we've talked about the different parts and pieces, we'll look at an example here of this engine that our buddies Keith and Jeff Dorton at Automotive Specialists let us borrow. So for the rear engine adaptation, we've started building up from our engine mount crossbar here. Again, we've isolated the vibrations coming out of the back of the block with these Energy Suspension transmission mounts, and then we have our DT1271 bell housing adapter in place here, and in this instance we've got our 1248 inertia wheel. So that's just an example of how you might adapt the back of, let's say, your Chevy or another small block to the Powermark or Black Widow engine cart. So now we've obviously got our engine mounted to the cart, and we're going to go through the steps to dock it to the Powermark or Black Widow. Steps will be the same because Black Widows and Powermarks actually share a base. They're common, carts are common, and so is this alignment bar. So to prepare for this off camera, we mounted a flywheel to the back of our engine, mounted our DT1204. This is a universal flywheel adapter. It's the one with all the different patterns in it. And then on the front of that, our CV joint to help us get smooth torque transfer into the drive shaft to the dynamometer. So the only thing you want to be careful here is to make sure that we don't have the end of the drive shaft deadheaded against the back of the 1204, or that we don't have the drive shaft installed far enough and just barely engaged on the splines inside the CV joint. So if you get it off of alignment a little bit, that's not a big deal. To correct for that, just knock the T-bolts loose in the front and back of the cart, and then take a little bit of weight off the engine with your engine hoist, and you'll be able to shift this forward and back a few inches and then just tighten them back up. Another good thing to remember here is we always need just a few degrees of misalignment in the drive shaft. We don't ever want it to be perfectly parallel here because the misalignment actually allows the CV joints to keep slinging grease to all different portions of the bearings. That way we don't burn up our CV joint. So when you're ready, you can take the brake off the engine stand, slide the cart forward, and the cart is going to dock onto the dowels on the base, and then get the drive shaft started and lock it in place with the over-centering clamps on the base. So we talked through the items we have available to help you adapt engines to either a Powermark dynamometer like this one, or the next size up in horsepower capacity, our Black Widow. We've talked about the importance of having torsional compliance both in the drive shaft and vibration dampening and all the connections between the engine and the cart to take stress off the engine, to take stress off the dyno, and most importantly to keep all of the vibrations that are emitted from the rotation of the engine from degrading our torque signal on the dynamometer. So if you have any questions or concerns, you can call us at 800-471-7701 or visit us online at www.superflow.com.